Hello, this is Mr. Collier, and today we're doing some arithmetic sequences. Okay. Now this sequence here is linear. You can think of it as a linear equation, and it's going to create terms that go up by a constant amount or go down by a constant amount of -3. So it's an arithmetic sequence. Let me first show you how you can generate all the terms on your HP prime calculator. If you go to apps function, apps function, let me clear all that. You can just type in 12 minus 3x. Okay, press enter, and then under num, now if you get these decimals, you can go to shift num setup here, and then just change the step size to 1. Let's go back to num, and oh, I thought that was changed. Let me see. Oh, I should start with 0, sorry. You should start with 0 and have your step size be 1. And then you click here and you get all the terms. First term is 9, then you get 6, 3, 0. You see the terms are going down by 3, which makes sense because we have a -3 in. Okay, so that's how we generate all the terms on our calculator. So in arithmetic, let's review the terms. So U1 stands for the first term, which is 3. D in this case is 2, because it's going up by 2 each time. So from the formula in our formula booklet, let me remind you what that is. In the formula booklet we have this formula here. Okay, so U1 plus n minus 1 times D. So it's going to be UN equals U1 plus n minus 1 times the D value is 2, which you can simplify if you want to. Yeah, so general term, okay. Oh, that's what we were supposed to do right there. Alright, so this is the formula from the booklet. There's also a formula for the sum of an arithmetic sequence, which we're going to use a little bit later. Okay, so let's take a look at some examples. Given this formula, given the formula of the nth sequence, give the formula for the nth term of the sequence. So again, we just identify what the D is. D equals 5 minus 2, which is 3. And U1, of course, is 2. That's the first term. So the formula is UN equals 2 plus n minus 1 times 3. And over here, D equals, you take one term and you subtract the previous term. So you could even do 7 minus 8 equals -1, and just verify every time you subtract you get a -1. Yes. Okay, so the formula is just UN equals first term plus n minus 1 times D. Don't write, be careful, don't write a -1 there. That looks like subtraction. You gotta make sure you put brackets in there so it indicates multiplication. Here's how many terms are there in the sequence. Well, we know U1, we know D. Okay, D is 3 because the numbers are increasing by 3. In this case, it's asking you how many terms there are. That is n. N is the number of terms in your sequence. So we're going to be solving for n, and this is the last term we know, and that's going to be UN. Okay, so we can substitute into the formula. And for UN, we can put in 104. And then we have the first term plus, we don't know, n minus 1 times D. You can, of course, solve this with your calculator, but it's only linear. So let's do 104 equals, this is 2 plus 3n minus 3. So 104 equals 3n minus 1. So n equals 105 divided by 3, which is 35. So that's the number of terms in the sequence. Okay, the next problem, we've got the first 3 terms of arithmetic sequence are these. Show that k equals 4. Well, you just got to go back to the definition of arithmetic sequence. So you might think of it as adding a certain number each time, but really it's when you're subtracting the terms, you always get the same value, the D value, right? So here, remember, 5 minus 2 is 3, and 8 minus 5 is 3. When you're subtracting, you always get the same value. That's how you set up an equation here. So if we take the second term and we subtract the first term, we need that in brackets, that gives you the same value, that's your equal sign, as if you take the third term, subtract the second term. They will give you the same value. And this is negative, let's write it out, negative k plus 10, because so we had this in brackets, so that means everything's going to be negative here, and this is going to be k minus 1 plus k minus 10. Simplify, we get negative 3k plus 9 equals 2k minus 11. I'll add 3k to both sides. We get 9 equals 5k minus 11. Add 11, we get 20 equals 5. That should be a k. So k equals 4, which is correct. It's to show that question so you can easily check your answer. It is indeed 4. Okay, in example 7, the first term of an arithmetic sequence is 5. The common difference is 2/3. Find the second and third terms and write down an expression for the nth term. I might actually do that first. The expression for the nth term is first term plus n minus 1 times 2/3, right? If I want to get, now this is going to involve some nasty fractions, so why don't I go ahead and use my calculator to make this a lot easier. You can type that into functions. 5 plus bracket x minus 1 and times 2/3. Okay, so now when we go to num, we'll get all the terms that we want. It's asking for the second and third terms. That's we have. It's too bad that you can't come up with a fraction for this, can you? No. Well, yeah, we have. That's a little bit annoying that this comes up with decimals rather than fractions. That's 5 and 2/3 and 6 and 1/3 right there. So maybe actually the app isn't the best idea for that one, because we don't want to be rounding terms in between. That would get a bit weird. So let's actually figure them out by just substituting in the values, like 5 plus n is 2 minus 1. Well, we can do that manually. 2 minus 1 is 1, so it's just 5 plus 2/3. Gives you, and then you click the fraction button, you can see it's 17/3, or even 5 and 2/3 if you wish. Maybe we'll do 17/3. Okay, so the second one is 17/3, and the third term is, we just add on another 2/3 to that, and you get 6 1/3 or 19/3. Okay, this makes sense. You're adding on 2/3 each time. This numerator is going to go up by 2 each time. Number C, determine whether or not this is a term in the sequence. So that's like un, and then you can substitute into the formula. Okay. Yeah, so there's a couple ways we could do that. I guess we could just type in, do this for 3 equals 5 plus n minus 1 times 2/3. You could kind of look it up in the table that we already generated. But we already have this on our calculator, so we can just solve for when it equals 49/3. Let's check it out. Let's do it that way. Apps function, let's do 49/3 here. Okay, so we're going to solve when this equals 49/3. We go to plot. I probably want to go to shift plot to change my window. X value in this case is like the number of terms, so maybe 30 is okay, but the values in these terms are pretty small, so I'm going to go to like 20. Okay, like 49/3, that's less than 20, so maybe I'll see everything. Let's see. Yeah, so I can see sequence is linear, so our arithmetic sequences are linear, so it goes up in a line. The red line represents 49/3. We just want to find the point of intersection. Okay, so when we solve this, we get n equals 18. Okay, it's the x value, n equals 18. Let me draw a sketch. Okay, we get 18 for n, and this 16.3 recurring is actually 49 thirds. Okay, now because that's a whole number, okay, then this is a term in the sequence. If you don't get a whole number, it's not a term in the sequence. N as the number of terms, it has to be a whole number, no decimals. Okay, since 18 is a whole number, 49 thirds is a term. Let's just leave it at that. Okay. Lastly, consider the finite arithmetic sequence. Okay, write down the common difference. So d equals, we have these two values here, 5 minus -3, which equals 8. That's the common difference. For b, find the number of terms in the sequence. You can do the same thing we just did. 1189 equals, actually, not the same thing we just did. We did it before, though. First term is -3 plus n minus 1 times the d value. Okay, and we can do this on the calculator as well. You can also solve it pretty easily manually. I already got something in there, so I can just change some of those numbers, like -3, and the d value in this case is 8. Okay, we want to see when that equals 1189. And now I know, maybe I can't see it right now, but I know it's going to be a line and a horizontal line, so I know there's no other roots. So I don't, even though I don't see it, I can go to intersection. So I know there's only one intersection. So this should work. So you get n equals 150. And we can draw same diagram to show work. Doesn't matter that I can't see it. I know that's 150 and 1189. Okay, so the answer though is n equals 150, just the n value.